Okay, good afternoon, everyone. Um, we're going to continue with what we started in class. Let me know whether you can hear me. You can put something at the chat, or you can put your hands up, or just comment, and then you can respond, and then you turn
Yes,
you.
sir, we can hear you.
Okay, so mute. After you talk, you can mute, and you can also ask question by putting your hands up. Uh, Josiah, your hands is up. What's up? Okay. So if you have a question, you put your hands up. You can also just type. Of course, I want you to contribute whilst I teach. I don't want to just talk. So you can always contribute by putting your hands up, and then you can talk. Because if all of us are talking, then it's going to be chaos. So if you want to talk, put your hands up and then you talk. Don't just talk. And you can also ask questions by typing. Okay, you can ask questions by typing anything. Okay. I was waiting for
Okay, sir.
few people to join, but the only thing I believe one or two of you might be double. I'm sure some of you are double or triple using the same machine. Okay, let's continue. So what we did in chapter 5 is equilibrium of a rigid body, and rigid body are solid bodies. Yeah, they are solid objects that they don't. We assume that whatever loading is applied, they don't deform, or if they are deforming, the deformation is negligible. So most things we see around our rigid body. So we have mechanics of rigid body. We also have mechanics of fluid. Okay, fluid. We also have fluid mechanics where the object might not be solid. So like air, earth, gas, etc. And some of the gas, etc., or fluid, they are compressible. Some of them are incompressible. So we have mechanics that do that. So, but here the mechanics that we are doing is like solid. And sometimes this solid, if we neglect its dimensions, then we can classify that as a particle. But here we're going to look at a rich body. In other words, we are taking the size, everything into account. Okay, so most things that we see around that are subjected to some kind of load, but it's at equilibrium or it's in equilibrium. And what we said is that in general or in 3D, if a rigid body is in equilibrium, then the condition for equilibrium is the sum of forces equal to zero. That's what we say. But take note that anything you're saying that you're saying the vectorial sum of forces equal to vector O, and then and the sum of moment vectorially equal to vector O. Okay, that's what we meant. And you can break each of them into scalar, into if like the object is found in the XYZ system space, then sum of forces in the X is zero, sum of forces in the Z is zero, sum of forces in the Y is zero. And also moment about X, moment about Z, moment about Y, all of them are zero. Okay, that's what we meant if a rigid body is equilibrium. Then we're trying to move to 2D, so we'll do few 2D, and then before we do 3D. But before that, you have to draw freeboard diagram, especially for the 2D problems. You have to draw freeboard diagram, and that is very important when you're doing the 3D. I don't really mind the 3D ones because sometimes it can be a little bit complicated. So 2D is that. But before we have to do 2D, we have to know something called a support reaction. So we learn a couple of support reactions. There are about 3 or 4 that I want you to know when it comes to 2D. Who knows what I said? Who remembers some of the support reaction I discussed in class? You can type for a 2D problem. Normally we have support that support our beams and etc. Who knows some of the support reaction I discussed in class? Sally and then Kweku Live. Sally, talk first. Sally, you were one of the guys that disturbed me, but I don't want to go to that issue. You're the one of the guys that disturbed the previous class. Whoever that Sally person is. I was muting and then you were muting back. You're muting back. Okay, so Mimi said rocker. Sebastian said roller. Robert say a hinge and then fixed support. Okay. Okay, so Sally,
Cylinder.
Kwiku, and Opoku 10, 10. What's the name? Opoku 10 off, 10 off. Okay,
Sir, please, you said a pin
a pin.
and
Okay,
a fixed support.
a pin is also called a hinge. A pin is also
Yes,
called a
please.
hinge. Sally, what do you want to say? Because you are the one of the guys that disturbed my class this morning, and I have to cancel the class.
Oh, sir, I'm sorry. Sir, please, cylinder.
Okay, a cylinder or a roller. A cylinder or a roller. Okay, a cylinder, a roller. So these are, then there's color, there's other one, but we don't want to go into all that because we can't solve other problems. So I have to limit the concept that we are working on. Okay, so let me cook. And oh, before that, we did some review, but so let me go through quick. So we did we look at the equations that in general, and we focus on 2D. 2D, sum of forces equal to zero, sum of forces in the x and y equal to zero, and moment about any point. That's how we say moment about the z equal to zero. But saying moment about z equals is the same as saying moment about any point on the object. So if you look at the picture here, if you look at this picture, this is a beam. Normally, this is like an engine. Then we can use some beam with some hook and a chain to hold it. So we are interested in knowing the appropriate chain to hold these engines, maybe whilst they work on it or something. Okay, so we'll draw something the freeboard diagram of the beam. We'll draw the freeboard of the beam. So we'll put this force here, and then there will be some force here. We'll cut the chain. You cut the chain, and then you show the tension. So the tension one and tension two. So we are interested in these tensions. Okay, and there the beam represent a 2D problem. The beam, analyzing the beam represent a 2D problem. Sally, when you put your hands up after you finish talking, you have to put your hands down. You have to click on this that icon again for your hands to go. Okay. So we talk about a roller. A roller allows movement this way, but it doesn't allow movement that way. So it means we have a reaction there. That's what we call a support reaction. And that support reaction is perpendicular to the surface. It's perpendicular to the surface. And then we have the pin or a hinge. A 2D pin or hinge can only rotate this way. It doesn't allow movement this way and then movement that way. So we have two support reactions, two force support reactions. Okay, two force support reactions. Okay, and sometimes we show FSFY, or sometimes we show the resultant of FSFY, where this resultant F is square root of Fs square plus Fy square, and the angle phi has to link with, let's say, tan inverse of Fy over Fx. So whatever the case, we have two unknowns. Either you use Fs, Fy, or you use only one single force at an angle. You use only one single force at an angle. And these two forces are meeting at 90 degrees. So if you draw Fs and you draw Fy at 90 degrees, the resultant is F at a particular angle phi. And that phi can be found using tan. And the F is like what? Do a simple Pythagoras. F will be the hypotenuse. Okay. And I'll show you how practically these things are connected. The other one that we'll be dealing with is a what do you call it? A fixed support. It's like you put something in a concrete or a wall, and the beam is in the wall, and it's like you put a concrete around cement, something. So it cannot rotate. It cannot rotate. It cannot rotate. It cannot move anywhere. So for a 3D, for a 2D, then the support reaction are Fs, Fy, and then there's a support moment reaction. These are support force reaction. These are support moment reaction. Okay. And then there's a collar, but I don't want to talk about collar. Rocker also is similar to like a roller. Rocker is similar, but only the way they design it is different, as I told you. Rocker allow the structure. So this could be a big bridge. Okay. And rocker could be small, it could be big, depending on that. So it allowed the thing to rock. It allows the structure to rock up and down. So it also allow movement, like the way the roller allow movement of the beam or the structure. So I start by drawing freeboard diagram of that in class. Okay. I didn't solve anything yet. In fact, we're going to solve for an unknown. But here I want you to get into the mode of drawing free body diagram. Okay. So this is a beam and this is a fixed support, like a brick or something. So what I did in class was you just draw the beam. It's not to scale, so just draw something nice. You can even use a line like this, but it's okay. You can just make a small rectangle to present the beam. And then you apply the load here. The load, if you want, you can show there's a little, the load is being applied on some little thing there, as you could see. So you can also draw that little thing. It doesn't matter. You can decide not to draw it. It's okay. So there's a little thing here, which is this. And then put before you put the load on, no problem. It doesn't change anything about the freeboard diagram. And then this is the end. This point is A. So sometimes we can use the letters to represent it, the forces. So there's AX and then there's AY. Okay. So and then there's a movement. And I was saying in class, how do we know how do we know the direction of AX, AY? Now they are unknown, so you can put them any direction of freeboard diagram. The only difference is that somebody will get negative, then somebody will get positive. Both of them are correct. Only you didn't show it in the right direction when you were doing the freeboard, but it's correct. That's what freeboard diagram is. Freeboard diagram contains known and then unknown, known and unknown. What do you call it? Forces or loading. Okay. Now it's left with movement. So to sometimes by inspection you can know which direction to point. Let's say AY, because if this is pressing down, you need a reaction force to go up to balance it. So that's why I show AY up to balance. In that case, I will get AY to be positive. But if you put it down, no problem, it's also correct. And also, I need to show movement. So I have to put an arrow this end or arrow this end. If you think this 1,000 newtons, apart from pushing it down, it's also called to cause the beam to turn about point A. So I can put this one here and I'll call it MA. So there are three support reactions. And you have to show distances. So from here to here is given as 2 meters. And from here to here is 6. Or you can do from here to here is 4. Don't duplicate. Don't do 6 and do 4 at the same time. So that's the free body diagram. We're about to do this, and then I left in class. Okay, so I'll switch to a white screen. I normally write on a white screen. Okay, so who wants to read the question? And then that we are not solving anything for now. I'm just drawing free border. Later we'll solve some problems. I will just drawing free border. So who want to read the question? Sally again. You the way I'm annoying with you. Okay, read.
Okay. An operator applies a vertical force F to the pedal so that the spring is stretched 1.5 inches and the force in the short length at B is 20 pounds. Draw the FBD of the foot pedal.
Okay, so FBD here means free body diagram, yeah? FBD here means free body diagram. Okay. So anytime you see me writing FBD, I meant free body diagram. Okay. So the first thing is to draw the structure. Okay. Draw this is the what do you call it? The linkage of interest. Okay. Or the pedal is all this. So you have to remove everything from it. What is this? What is this? What is that? And that is what is here. That's what is here. That's a red thing. That is what is here. Okay. What is that? Robert.
Yeah, it's the hinge support.
That's a hinge support. Thank you. That's a hinge support. Okay. So we'll take the hinge off. Okay. So I'm going to draw the exactly how the thing look like. So we have this. What I'm using might be difficult to draw, but I'll try. If I have a marker on a board, that's a different thing. So it goes like that. and then it bends. So if you are drawing, I'm sure you do a better work than what I'm using. I'm using some pad stuff. So what I'm doing is I'm trying to just draw what is there. It didn't come out well, but it's okay. So at this point, let's show what is known first. What is known is the way the guy is pressing it. The guy is using his boot. Okay, he's using his boot here to apply a force, F. We cut the linkage. This is a link, it's a bar. So there'll be tension in it. And this is like a spring. Also, there'll be tension. So you cut them. One is at this point here. So we cut it. I believe we show the arrow this way. And then one at this end, you cut it and you show an arrow that way. Okay. The force in the linkage, this linkage is 20 pounds. So you put it there. The force in the, what do you call it? This is not given directly. Okay. The force in the spring is not given, but they gave it a stretch. After the guy have pressed it down, they give us how much the spring is going to stretch as 1.5 inches. So we know the spring constant or the spring stiffness of that. So we can find that using F equal to K times the extension. Or you can also say F equal to K times extension. Then the force in the spring generated will be the 20 pound times 1.5. And 20 pound times 1.5 is 30 pound. So this is 30 pound. Then you put it on your freeboard diagram. The next one is, and listen carefully, we don't have any coordinate system here. So you can see like this is an X, this is a Y. Okay. So you can show, let me do another one diagram here. This one didn't come out well. Okay. Somebody can decide to show the reaction here. This reaction. You take the hinge off and then you put what the point is A. So I will say AY. And then you can see this is AX, no problem. But if you think, look at this, F is pressing down. So AY will balance F. Oh, but if you know, look, 20 newtons is 20 pounds going here, 30 pounds going here. So if you think you can show the AX to the what, that else you get negative, but no problem about negative AX. No problem with that. Okay, no problem with that. Then look at this. I remember I told you that this is like, you can also take this as one direction and this as another direction. If in that case you have to show some angles, okay, in that case then you have to show some angles. If you try to show them this way, fine. You can also somebody can also show the reaction forces. Okay, let me do this one here. So this one is going to be our AY, this point A, and then this is going to be our AX, and that. Then you can put some distances. There's some distance here which is 5 inches, and I make my diagram too small, so it's difficult. You can make it a little bit big. I need to show the distances between these two, from here to here, from here to here, and this is 1 inch. And this example is in the third. We can look at it, 1.5 inches. So I was trying to say something here. So let me go back and say it. Somebody can also show like this is as AY and this is at AX, no problem. But in that case, you have to capture this angle. You have to capture this angle. Whatever this angle is, you can capture it from the diagram. It's not difficult to capture. It's not difficult to capture. Okay. So that is the freeboard diagram of the hot, of the pedal, of the foot pedal. So I'm just trying to give you a picture. Please can't hear a thing. I believe the rest can hear me, isn't it? Which audio?
We can hear you, sir.
Okay, so if you can hear me, please sort out your mic. Let's go to the next example 3. Once again, I'm drawing freeboard diagram. So Who can help me what to do? We are not computing anything yet. In fact, what we are going to calculate is actually the support reactions. The support reaction I've been showing is what we need to compute. Okay. So who can help us draw the free body diagram here? Who's going to help me? I'll draw the beam. I'll take everything away, then I'll draw the beam. The beam look like a rectangle. Let's draw a rectangle. If you want to draw it and look the way it look like here, fine, no problem. So you can make like this and then make here a little like this before, no problem. But this is nothing. It's just a sketch. So just make a rectangle. Now, what is on at A?
You hear them? Can you hear them now?
What is at A? What do we have at A? Oh, what do we have at A? Yeah, quick life.
Simply the support reaction. That is a
You, yeah, so say pin. So don't say support reaction. It's a support reaction. So what type of support reaction? It's a pin or a hinge. So what do we do? What should I do? I'll take it off. So if you take it off, you have a hole, like a hole in the bar, in the beam. What should I do? I'll put two forces there. One is AY, and the other one is AX. And then what do we have at B? What do we have at B? What do we have at B? B is not a hinge. Chinibua.
That is a ruler.
So it's a ruler.
Okay, it's a roller. Okay. So if it's a roller, we take it off. We take the roller off. Remember, we are drawing football that only the beam. If only the beam. And take note, a beam that is supported by a pin or a pin and a roller is called simply supported. So take note, a simply supported beam. I've also told you something about a cantilever beam. A cantilever is the one the beam is fixed to something. It's called a cantilever. And then a beam that is on a roller and a pin, or a pin is so-called simply supported. It is simply supported. Okay, so I'll use the letters there. So I'll call this one BY. Then I have to put the load. So these are the unknown load or the unknown support. And normally that's what we look for. Maximum, it can be only 3 unknowns. So as you could see them, 3 unknowns. How do I show the forces? Or how do I show the load? What should I do? Who want to answer that? In fact, and I should have done that first. So I'm going to move this down a bit. And you have to do that calculation first. So what should we do? Who want to help us? Who want to put the hands up and answer that? The previous questions we did, look at this. It was all pointed loads. All this one, it was just pointed load, including the example 1. It was all pointed load. Look at this, pointed load. Here also pointed load. Apply load was pointed. We assume that the pressure the guy was applying to the pedal is pointed. It's not. Yes, if someone want to increase the accuracy, the person can model it as distributed load on the pedal. But we are looking at it from only this side. So that's why it's 2D. We are looking at it from this side. That's why it's 2D. Change the distributed load to pointed load. That's what Jerry is saying. Jerry Justice. So he said we should change it to what? We should change it to pointed load. And how do we do that? How do we do that? We break them into what? We've done this before. We break them into 2, 1 and 2. Is that right? Or you can also go for 3, 1, 2, and 3. So let's do that. And you can even find the overall resultant, but you don't need to do that. Don't waste time. I didn't ask you to do that. That's the question we did for previous question. Here, they didn't ask you to find overall resultant of the distributed load. So don't do that. Just break into 2 and show them. So what we'll do is that we'll find a certain FR1. And then what is FR1? Then we find X bar 1. And then FR2 and X bar 2. So who want to help me? FR1 is segment 1 is the rectangular. So who want to help me with the value? Who want to help me with the value? 200. Okay, if you're not saying 200 times what? 7, which is 1,400, and it will be newtons, and it's going down. The corresponding x bar here, they didn't ask you to find FR x bar, so you can decide to measure them from A or B. It's up to you. But let me measure x bars from A. Then this is half of 7, and that is 3.5 meters. And then what is FR2? What is FR2? Who want to help? What is FR2? Okay, if you're not talking, all right. Half base.
400 times 300.
Half base. So what is the base?
You can see the height up there.
You can't see the height. Okay.
Okay, thank you, sir.
So what is the base? Sometimes coming in and talking like that without putting your hands up, there's no problem with that because you don't.
Join the meeting.
Hello. So, what is the base? The base is 3, and then what is the height? Hello.
400.
Is the height 400? Remember, I told you that you make some mistake.
The height is 200.
The height is 200. I told you make that mistake. That's the reason somebody says 600. I told you you will make this mistake. Didn't I tell you in class? I told you to be very careful. So it's for up to here is 200. So from here to here is the 400. So you are looking for this to here. Okay. So this is 300.
Okay,
It's a mistake that you are likely to make, but if you learn, you will not make it. And then what is? Oh, I have to reference this. This is from A or from B. Then what is x bar 2? Who want to help? Who want to help? So, I've a mega, and then is it Jotipe? Can you put your mic off? I've a mega Henry Selom. Okay, some people have typed like somebody called M. Okay, Sally, do you want to say something? Okay, so somebody called M sash, right? 4 plus 2/3 of 3. Okay, so the center is somewhere here. For the rectangle, the center will be somewhere here. And this, the center is somewhere here. So you have to find this whole distance. And for this, it's from here to here. You can also measure them from B. Here, we are not doing like in the previous chapter. They didn't ask you to find overall result, and we don't need that. Somebody says, I can also do 7 minus 1/3, no problem. Or you can, in fact, also just do 1/3. You can also do 1/3 of 3. That is from B. And we just show it. Here, we are not find the resultant. I have a reason of saying that. We are not find the resultant of the 2. So this will end up to be what? 6 meters from A. So let me draw the freeboard diagram, another freeboard diagram again here. So let me move this up, down. Let me move this down small so I can have a space to show the forces. Somebody can also draw the beam. Let me show you. And
So
put
this is 8 meters from A.
the what?
I think it's 8 meters from A.
8 meters from A. Are you still in bed? Are you still sleeping? The whole thing is 7 meters. So how can it even be 8 meters? The whole length is 7 meters. So how can it even be 8 meters? Who is that? Minus 20. Hello, who is that? Was it Kwame? Kwame, the
No,
whole
sir.
thing is
Please,
7 meters. So how can it be 8 meters?
sir, it wasn't me, sir.
But who was that? Okay, so let's show the forces. So one is right at the middle, which is 1,004 newtons. So from here to here is 3.5. And then the other one is somewhere here. Let me put it here small. And if you want from here to here is 1. That's why I say you can decide to show it anyhow you want. That is 1 meter. Therefore, from here to here is 4.5. So that is it 2.5. So this we've been able to show, and this value is 300. This value is 300 newtons. And you have to show the points A, and that is point B. You can put some point there, no problem. You can even put a C and a D, no problem. Now, so I've used two forces to show that. You can also combine, just a note.
Is sound coming?
You can combine FR1 and FR2 so that you get overall FR at a distance XB. And then you show your two reactions. You can also do that. But here they didn't ask you for that. Here they didn't ask you
Join the
for that.
meeting.
They didn't ask you for that, so you don't need to do that. Okay, you don't need to do that. So that is our free body diagram, and they will ask us to calculate AX, AY, BY. We'll do that very soon. Abubakari, what's the question?
Sir, please, I'm quite confused of how you drew up to the 2.5 meters. How you drew the free body diagram and you indicated the 2.5 meters.
Yeah, the whole thing is 7. Can you see? The whole length is 7.
Yes.
Can you see it?
Yes.
And if you do, maybe I did this one. If you do 1/3 here, 1/3 of
Okay.
1/3 of 3, you get 1. 1 from B. So from here to here is 1. Or from here to here is 6.
Yes.
So if from here to here is 6, it means from here to
Okay.
here is 1. And if from here to here is 3.5,
Okay.
3.5 add 1 is 4.5. And if you take 4.5 from 7, you
Okay.
get 2.5.
Okay. So if we rather take it from the base there, that's from 2/3 of 3, we'll get we'll rather be getting the 2. So why isn't the other
No,
side 1.5?
if you do from the base,
Why didn't we?
if you do from the base, it's not 2/3, it's 1/3.
Okay. So the rather the apex rather.
Yeah, from the apex is 2/3.
So the 2/3, right? I thought that side would be 2. Why didn't we rather choose 2
Okay.
instead of? Why didn't we? So why didn't we put 2 instead of 2.5 and 1.
Hold on. It's 2/3 from this line, and this line we are seeing here, from here to here is 4. But this we are showing here, we are showing this as 3.5. So it's left with some 4.5 left. This is 2/3 from here, which is 4 meters from here. But the one the line I drew here, this force here, is 3.5. So there's some 0.5 left. That's why it's added to the 2 that you want to talk about. So that's where the 2.5 is coming from. Anyway, let's
so where I'm confused is why isn't the 0.5 added to the 1 but added to the 2?
What is,
or you can why the 2.5 left, why isn't it added to the 1, the side that is 1, but it is added to the 2?
In reality, I'm not just adding anything. Hold on, I'm not just adding anything. I'm not adding because of that. I have to add it anywhere I want it. No, I'm not doing that. I'm just saying from here to here is 1 meter. From here,
Okay.
not to this side, though. From here to this first, that's the center of the
Okay.
this is 3.5. So therefore, what is
Okay.
left? What is left is what I put there. So I'm not just adding anything.
Yes. So what is left to be 3.5? Or
Can somebody add this? Whether it add up to that? What is 3.5
7?
add up? Is 7. So what's the problem? So this is 7. The whole
Okay.
length is 7.
Yes. So it's 7, but the 2.5, the side that is
Anyway,
2.5. If you take it.
take time and go through, please.
Okay. Okay.
Take time and go through. Okay. Now, the next example, let me go to lecture notes and then show you something. So I'm intentionally showing how to draw free, but I didn't calculate anything yet. I didn't calculate. And Abubakar, I've not even added anything yet. So now, we don't just draw the free. Somebody asked a question, do you draw free border again after you find the solution? No, Kwame, we don't do that. So if somebody teach some of these things, it's wrong. So when you show you draw the free body diagram, free border contains known and unknown forces. So when you calculate any unknown and you get negative, don't change the free body diagram. Don't draw the free body diagram again. We don't do that. Okay? If you get negative, don't worry. It's just what it tells you that it's just opposite to the one you show on your free body diagram. Kwame, if it's clear, let me know whether it's clear. You can say yes or okay. Paul, yes. If you do 1/3 from B to be 1. So that's why I put the 1 meter there. Okay. So how do we solve a 2D problem? The first thing is to draw a free body diagram. 2D problem, I want you to draw a free body diagram. If you draw a good free body diagram, the question is solved, just like we did for a particle. But here, the only difference is that it's a rigid body, so you have to put some distances and angles and stuff like that. Then you apply 3 equations. Normally, you can only have maximum of 3 unknowns. And sometimes you can choose a coordinate system. You can see this is your X, this is your Y, but normally that is not necessary. So let's start with our first example. So I'm switching to my white screen. Yeah. So who want to read this one now? Who want to read this?
Determine the component of the support reactions for the beam loaded as shown. Neglect the weight of the beam. Take theta to be 0 degrees.
I like that. I didn't really say take, but actually that's the word there. Thank you. Whoever said that. Take. I like that. I didn't put the word take there. Oh, it was in the lecture notes. I don't think so. Huh. Interesting. Who was that?
Sir, please, Larry.
Thank you. I didn't say take, but that's a strong word there. Take. Yes, take. Because theta can be anything. Theta can be 60, can be 30, can be 20, can be anything. But we want to keep it simple. So we want to make it what? 0 degrees, so that this thing is like this. It's like this. Okay, first of all, what is this? And then what is this? What are these support? What are the support holding the beam? What are the support holding the beam? Robert, is it like you want to talk?
Sir, yes, it's a rocker.
Which one is a rocker?
The support at B.
Okay, and then what about A? What about A?
The one at A is a hinge support.
It's a hinge or a pin. Okay.
Sir,
So
please,
what?
it's a hinge support.
So here it say normally they will say magnitude of the component. Find the magnitude of the component. So we don't care about negative or positive. We want the but we want the components of the support reactions. So here we are going to calculate our AX, AY, BY, and stuff like that. That's what we are looking for. So they will not directly ask you to draw free body, but you have to draw free body before you solve the question. If you just solve the question, and if it's right, if I'm grading this one, I will not even grade, I will give you 0. Because the question you are solving is based on the solution is based on the free body diagram. So let's draw a free body diagram. Once again, is this similar to what we did? So you make a bar like this, and then we take the pin off, and we show AY, AX. The loading is only in the vertical direction. So when you finish, you're going to see the AS will be 0. If the loading was at an angle, it will have component both in the X and Y. So the pin will generate a reaction force in the X. But let's put it. So then there's a load here, which is 4 kilonewtons. And then we are taking the roller to like this. So perpendicular to the surface here. And that is, call it BY. Let's label the joint A and joint B. Okay, and then let's put our dimensions. This is 6 meters, and that is 2 meters. Okay, cool. So we finished. This is the freeboard diagram. Now, if the beam sometimes have a weight, and the weight sometimes might be, let's say, 0.2 kilogram or grams or something. So sometimes the beam's weight is small compared to the applied load. So sometimes we will neglect it. So anytime you are doing a problem, they don't give you the weight of the beam, it means you are neglecting it. So anytime you don't say anything about the weight. If it has a weight, then we put it at where? If the beam, we are taking the weight into account or the mass into account, what do we put the weight?
The center of gravity.
The center of gravity. So we put it right in the middle, and this is 8. So we put it at 4 meters from here, 4 meters from here, and that's what we'll do. Okay, so we are neglecting. That's why we don't put anything. So how many equations do we have? 3. And we have 3 unknowns. So the first one is, it says sigma f of s is 0. So ax is 0. Is that true? That one, there's no doubt about that. Is straightforward. Ax is 0. And then you take, the way you apply it doesn't matter. Then you can take moment about A or B. Any of them is fine. Normally, you can take moment about the place that has more on that. If you take moment about A, it's like put your finger at point A. Put your finger at point A. Then this BY will try to rotate it this way. And 4 kilonewton will try to rotate it that way. So they are going opposite. So I'll get what? BY times 8 is equal to what? 4 times 6. Did everybody see that? And if I remember, I told you the way I like to write moment. I'll say this side minus that side. And this case is not like in chapter 4. In chapter 4, we'll find the resultant moment. So I'll say this side minus that side, done. But here is this side minus that side equal to 0. But I would like to write it that this side is equal to that side. Everybody clear with the equation I just wrote down? Everybody? Everybody?
Please come again.
What I'm saying is that in chapter 4, don't confuse chapter 4 with chapter 5. For chapter 4, we're looking for resultant moment. So I normally say this side minus that side, done. I choose one side as positive. But here, you have a beam, and some moments are turning this way, some are also turning that way. And this is in equilibrium. That's chapter 5. So when I'm writing the moment, I will say those try to turn this way equal to those try to turn that way. I can also say, so let's say the total moment this side is M1 and this side is M2. I can write the equation as M1 minus M2 equal to 0, or M2 minus M1 equal to 0, or M1 equal to M2, and I'm using the third option. And I did the same thing for forces as well. Go and check chapter 3. I did the same thing for forces, a particle in equilibrium. So if you take moment about A, the 4 kilonewtons will try to turn this way. Call it, that's your clockwise. And BY will turn in the counterclockwise. So BY times the distance 8 equal to 4 times the distance 6. And then you just press the calculator and you get your answer. Is it clear for everybody now? Let me use the calculator now. What's the, I think this is 4 times 6 is 24. And 24 divided by that is 3.
So please, why doesn't the B have an X component?
If I understand your question very well, but I don't want to answer it directly. So can you come again with a question? Why do you say B? There's nothing like B. There's nothing like B has doesn't have. So can you come again? If you come again, then I'll answer you. Or if can somebody help with what he wanted to ask? Who can help
So
me?
you You didn't show from the free body diagram. You didn't show the bx.
Can somebody answer him? He have improved on his question. So can somebody answer him?
So is it because of the support this thing?
Then if you know, then don't answer yourself. If you shouldn't have asked the question. Kweku,
So
live,
I
do
was
you want to
sure.
answer him?
His question is answered.
He has answered his own question.
Yes, please.
Mimi say it has only one support reaction. So go and look at the notes that I gave you. It's a rocker. A rocker and a cylinder always just have one support reaction perpendicular to the surface. So we are not just putting any B, S, B, Y, anything. I'm using
Yes, sir.
B. You could have also used like some people use N and R for support reaction. So you can write things like N, B, Y or R, B, Y. But I want to make it sure. So I normally use the letters at those places for the support reaction. So B is nothing done. Then, do you know I can also take moment about B and I can find AY? Everybody okay with that? Hello? So let me write it here. You can also take moment about what? B is equal to 0. And that will allow you to find what? AY. But you can then use summation of forces in the Y equal to 0. In other words, sum of forces upward equal to sum of forces down. So you're going to get AY plus BY, they're going up equal to 4. Can you see that from the picture? AY plus BY is equal to 4. Can anybody see that? Okay.
Yes, sir.
Then you sub in and then you get your AY to be 1. They have to add up. Your AY and BY have to add up, in this case, to 4. And you're done. So we find the support reaction. Very, very straightforward. You don't need to start with sigma F first. Normally, you can always start with the moment. Because the moment, always take moment about the point that has more support reactions. And then you can find another one. Then you can do summation of forces in the X, summation of forces in the Y. But sometimes instead of doing summation of forces in the Y, you can do another moment. So if you are also done moment about B, you could have also easily gotten AY. It's up to you. Let's move on to the next example. 5. I've just intentionally make some small change to the previous example. So who can tell me the difference I've done? It's the same beam, but I've just added, increase the complexity small. So look at the question and tell me what I've added to it. I'm now solving a lot of problem for you.
A moment.
Oh, I've added a moment, a couple moment. Remember couple moment? So this could come as a result of what? Couple. And I told you couple moments are free vectors, so you can put them anywhere on the beam. And it's already moment too. It's already moment. 200 newtons per meters. What else have I changed in the question? So I've added a couple moment or a moment. What else have I changed in the question?
Theta is equal to 60 degrees.
Theta is equal to 60. So the rocker is not perpendicular, but it's at an angle to the beam. Okay, it's an angle. So let's draw a free body diagram. We are finding the same AX, AY, BY, and so on and so forth. That's what we are doing. So I'll draw the same thing again. Take this off. This is AY. And that is AX. There's a couple moment. Let me put it somewhere. What is 200 newtons meters? Okay. And then there's the pointed load somewhere here. What is 4 kilonewtons? Now, this time the rocker is at some kind of angle. And we have to be able to figure out what this angle is. Either to the vertical or to the horizontal. We have to figure out what this angle is. And we can, once again, it's not really pointing the y direction, so you can call it anyhow. You can call it like FB or something. You can call it like FB. Okay. You can call it like FB. Because it's always have to be perpendicular. Always have to be perpendicular to the surface. You can call it FB. But we know this angle. This angle is known. So who can be able to figure out what these angles are? At least one of them. Because this and this meet at 90. So let me show how we're going to figure this out. If you look at this side here very well, they've given this angle to be, this is supposed to meet it at 90. They've given this angle to be 60. So this angle is what? 60. Is that true? Hello?
Yes, yeah, it's true.
Okay. So this angle is what?
Yeah, we can't see a cursor or something.
Oh, really? You can't see me writing?
Yeah, it's very small. You can't see anything. You can't see you pointing the cursor, like, you can't see.
No, I'm writing. You can't see this small angle that I'm writing 60 and stuff like that.
I said we can see, but at first, like, you're showing the cursor.
Okay, so this angle is 60. So I'm making it big here. So this is 60. This is also 60. And this have to be 30. Is that true? So this, and if you draw very well, this have to be 90. So this is 30. And this is 60. So you have to put only one of them. So you have to figure a little bit. This angle is 30, that is 60. Okay. So let me zoom out small and go back to the program. So this angle, which one do you want? Let me do the horizontal one. This is 30. Or this is 60. Just put one of them. And this point is A, and that point is B. And this distance is giving us, let me put it on top. This is 4 meters, and that is 2 meters. Okay, make sure you put the arrows at the end. So there's arrows here. There's arrows at the ends. Very, very important. If you show a force without the arrow, then it's not good. Okay, so who's going to help me solve this now? How many unknowns do we have? And that's what we're looking for. We are determining the components of the support reactions. How many unknowns do we have? And how many equations do we have? How many unknowns do we have? And how many equations do we have? Yeah, quick life.
Sir, please a question. How did you manage to get that the 4 meters up there? Because I think in the
Oh, sorry.
question 6.
Sorry, 6. Yeah. Thank you. Thank you. 6. Okay. Quick, yes, go ahead. Okay, so we have 3 equations, 3 unknowns. Yeah, somebody, okay, Prince, thank you. You also say 6 meters instead of 2 meters, 4 meters. So, which one will you go for first and why? How many equations and what are these equations? Which one will you go for first and why? Who want to talk? Emmanuel or Immanuel? Immanuel. I don't know how you pronounce your name.
Sir,
Yes.
sir, please, before you said that, the side with the most number
Exactly.
of the support reaction.
Reactions. You take moment
Yes.
about there. You take moment
Yes.
about that point. And normally that's the first thing you should do to make your work easier. So where should we take moment about?
The AXAY, that side, the A.
The A.
So,
No, don't worry about A. The point. We are taking moment at the point. You see, we are taking moment about the Z. If this is like the X, Y plane, then it means the Z that is coming out. So every point here, A, B, are like they're on the Z axis. So we don't see moment about Z. We just see moment about the point A, B, C, that order. So we take moment about A is equal to 0. Please, anytime doing chapter 5, I keep on reminding you about chapter 4. Chapter 4 is not equilibrium. You keep on finding, so don't put anything called zero or balance the moment. Yeah, it's resultant moment. Here is balance. This minus that equal to zero, or this side is equal to that side, and I do that. So who's going to help me write this? Somebody should read for me, and we go on. Especially if you are those that cause the trouble in the morning section that are closed, I have to call the class off. You can talk, and I have all their names down. Mm-hmm. So who want to talk? Who want to help me do this moment?
Sir.
Yes.
Sir, what I think.
How do you pronounce your name?
Larry.
Oh, but you have something there. Whatever you have, there's something iPhone.
That's my surname, Plani.
Plani.
Sir, just Larry.
Oh, Plani. Mm-hmm. Plani Larry iPhone. Mm-hmm. Go ahead.
Sir, what I'm thinking is,
mm-hmm.
We want to find the FB.
Yes, very good. It means
Yes,
you can easily get FB because you are taking moment
yes.
about A. So A, Y,
Yes, sir.
A, X.
So,
hold on. A, Y, A, X are passing through A, so they will not have moment. That's the meaning.
okay. So our FB times
Hold on. Let somebody come.
Yes, sir.
Let somebody come. Immediately you say times, then something is going to go wrong. Yeah, Chunibwa. Chunibwa Daniel. Chunibwa Daniel. Oh, you have your answer. Then put your hands down. Who else want to come? Who else want to come?
Say Jerry.
Okay, Jerry Justice.
So I'm going to have 200 new.
There's a guy is it the entertainment industry, something called Jerry Justice or something?
Yes, sir.
Okay. Are you related to that guy or something?
No, sir.
But is your name Jerry Justice?
Yes.
Okay, go ahead.
200 newtons plus FB sine 30 equals 0.
I like that. 200. I just lied. I don't know whether it's right or wrong though. But 200 newtons plus F 4 times. So did you say 4 times?
FB. Okay.
So please, won't we add a distance?
Sorry.
I'm coming on. Let's do something quick. Look at the picture very well.
No.
If you put your finger at A, how would the 200 rotate the beam? Put your finger at A. Just put your finger at A. The 200, how will it rotate A? First of all, let's take the 4. How would the 4 rotate it? About A. This way, is that right? Hello? Let's take the 4. 4 rotated this way, is that right? Call it clockwise.
Yes, sir.
And
Yes,
this one in your diagram is shown as counterclockwise, so they have to be in the opposite. Then let's take the FB. The FB, what do you have to do with the FB? You have to break it down into FB sine for the horizontal, FB sine for the vertical, FB cosine for the horizontal. If they don't give the thickness of the bar to you, that means it's going to pass through A. So the FB cosine will not have moment. It's only the FB sine. And that FB sine will try to rotate the beam this way. So this and this will be on the same side. So it's going to end up to be FB sine 30 times the distance from A, which is 8, plus the 200 is equal to 4 times 6. Pause and think and look whether you've gotten it. And I believe nobody's going to ask me to multiply the 200 by a distance. Who can answer that question? Do we have to multiply the 200 by any distance?
No, sir.
No,
It's already
sir.
It's already
Yes,
moment.
because we found them.
It's a couple moment. It's a free. It's a couple moment. If you don't have a mechanic today, go somewhere. Let's go to Makola. Somebody is saying I should do 4,000 times 6. Is the person right or wrong? And I did 4 times 6. What's the difference? Who want to? Oh, this is FB. Sorry. Somebody said I should do 4,000 times 6. But I have done 4 times 6. Who can comment? Chunibwa. If you put your hands up.
That is kilonewtons.
No, it doesn't matter. Who can talk? It means if I do mine this way.
I can add the kilo to it.
Oh, after getting FB, I'll get my answer in kilonewtons. You will get your answer in newtons. That's the meaning. Hello? I'll get my answer in kilonewtons. You get answer in newtons.
The 200 is not 200.
Oh, thank you. Thank you. I like you.
It's not kilonewton meter, so then it's going to affect.
Yes, that is okay now. Thank you very much. Thank you. You spotted it. Thank you. Thank you. Okay, so somebody is saying that this is newtons meters. So this case you have to change this. If this was kilonewtons meters, then there's no problem. So the person who said this is absolutely right. We have to make sure it's consistent. And I was nearly killed. It's like they started that. So now it's consistent. Is it consistent now? You will add your K later on. Oh, not necessarily. Is it consistent now? Is it consistent now?
Yes, sir.
I'm finding hard to picture that. Yeah, Ishmael, maybe you didn't listen to me when I was doing chapter 4. When I was doing chapter 4, we studied something called what? Couple. So it could be two forces that was acting on the beam. One was like this, one was like this. And this one was, let's say, 20 newtons. The other one was 20 newtons. And the distance between them was 10 meters. So if you do the couple, you end up getting 200 Newton meters. And let's say it has already been done. Once you finish, you remove it from there and you just put a couple moment on it. So it could be 2 bars. So you have the beam. In the physical process, you might have the bar, the beam. And sometimes this is not what I show. So you might have a small beam here, another bar, and another beam here. And they apply a load on it. And they apply another load here, the same. And this is 2 newtons. This is 2 newtons. Somebody asked me to give a physical meaning. Yes, and this is 6 meters. So the couple moment on the beam is what? 12. So I will not draw these brackets again. So instead of, I'll put what? This, and I'll put what? 6 times 12 newtons meters. Yes, Francis, yes, you're allowed to unmute and ask question. But sometimes maybe 2 or 3 people will be doing that at the same time. So if you put your hands up, I can ask, then you ask your question. Yes, Ismail. Thank you too for understanding. And couple moments are free vectors. Read a slide. I put something there. They are free vectors. So after you calculate them, you can easily put them anywhere on the beam. You can put them anywhere on the beam. Okay, who have used the calculator to get me an answer? Please don't waste too much time here. I don't need your show working. Let's get a calculator and enter, divide, and then give me FB. And just give me FB. So who has a value?
6,000.
6,000. Please, I do not, what do you call it? I don't have what do you call it here. I don't have answers to some of these things. So whatever numbers you give me is what you write. So sometimes if you go and you find out it's wrong, don't come and this thing. Whatever, if you find the right thing, that's the right thing. So whatever your mate give me is what I write. Okay. Now, what's the next thing to go? Since you got FB, it means we can now do what? Hello? You can do any of them first. You can do sigma f of first equal to 0. That will allow you to get AX, or you can do sigma f of any of them.
Sir,
Yes.
please, I don't think your answer is right too.
So give me yours. There's somebody giving. I know which one is right. I don't know. I've not used calculator.
Five.
The answer is wrong.
5950.
5.95
So 5
K
550.
Yes. 5.95 kn.
Okay.
Point. My place is at
Okay, that's for whatever you give me. I'm not interested in answers. I'm interested in the procedures. Let's go on. So since you're able to find what is FB, it means we can now find AX. And then because there's a component of FB that have to balance AS. And there's a component of FB together with what? The 4 kilonewtons that have to balance AY. So let's do AX first. Let's do AS first. So what do you have? AS will be equal to what? FB cosine what? 30. Can anybody see that? Can everybody see that AS will be equal to the FB cosine 30?
Yes, sir.
Okay, so I'll write that one here. So FB is equal to, sorry, that's the FB. AS, sorry. AS equal to your FB cosine 30. And then you put whatever your cosine in and you get your answer in newtons. And you can write the answer in kilonewtons. The reason we do that is when you are reporting it, the answer, because the force was given as kilonewtons, you have to report your answer back in kilonewtons. That's what we like to do. And then you do summation of forces in the Y. Let's see what we can do. So look at this. Your AY plus FB sine 30 is equal to the 4 kilonewtons. Your AY plus your FB, what about your FB here? Sine 30 is equal to 4. And then you work whatever AY is and you get an answer. Okay. Let's move on. Let's move on to the next example.
Sir, please question.
Yes.
Sir, please, my question is pertaining to the free body diagram. It is appropriate to locate the FB sine 30 and FB cos 30 on the diagram.
I don't have issue, but I know everything you're talking about, and if I want to train you very well, when we draw, because all of us people have taught you before, and people teach mechanics and they teach all sort of things. So people, sometimes people don't understand, so they will write the resolving already in the free body diagram. So they will write the FB like inclined plane like you've done before. They will write the something cosine 30, something sine in on the free body diagram. It's good. It's not wrong. It's correct. But a very good work, we don't do that on the free body diagram. But when we are writing the equation, that's what we resolve. But the mistake maybe you might do is this, and that's the one I don't like is some people will show FB, then on the same diagram, they also write FB sine cosine 30, FB sine. So in that case, you are telling that there's 3 forces now. So either you take this off, which I will accept, you take the FB off, and then you show FB sine, FB cosine, FB sine. Do you get my explanation very well?
Yes, please, sir. So meaning if you want to show that the sine cos, you have to take off
and yes, you've done 3. Because I want to teach you so that you also teach somebody very well in future.
Okay, thank you
but
very much,
the good thing is we don't do the resolving on the what? On the free body diagram. Isn't it?
Okay, sir.
When you are writing, then that's how to do it.
Okay, thank you very much, sir.
Okay, you're welcome. Okay, let's look at the next question. I wanted to finish too, but since the time is almost gone. Okay, let's do about 2 more. If I can do let's do this one. Let me just explain this one for you, then I'll do the next question. I'll not do this one, I'll explain it. Okay, have you seen this question? Hello. I think this is in the textbook, so you can look at it. Hello, can you see this question?
Yes.
Yes, sir.
If you respond those ones, I don't have issue. Then you turn your mic or you mute.
Yes, sir.
Sometimes the problem we solve. Sometimes they don't give the thickness of the beam. They don't give the thickness of the beam, so we neglect it. And sometimes too, we neglect the weight or the mass of the beam. But this question, they've given you this distance. Oh, who is that? Aberdeen. So can't this person sometimes realize? And if you mute, then it doesn't mute. They've given this distance here. I don't know whether we should solve this. Okay, I will just solve this. They will give me this distance. So in that case, if you resolve the 600, you're going to get 600 cosine, 600 sine. The cosine, one of them will be like this. The one of them will lie here. But it's not passing through the origin. The line of action is not passing through. So it will have a moment of something times 0.2. The other question that we did, like this one, what is the one we did here? Like the one here we did FB. The one that is this, we assume that is the line of action is passing through A because they didn't give it the thickness. So we are neglecting the thickness. But if they give the thickness, you have to take it into account. You have to take into account when you are resolving. And this question, I wanted you to do it without taking the weight into account and then taking the weight into account. And the weight always acts at the center of gravity. So let me draw free body diagram for only B, and then I can wait to look at the next example. The computer engineer, I know you guys, the reason I'm finishing early, 30 minutes, I want to finish, do 1 hour. I think you guys have a class at 2:30 or 3. What time is it? Computer engineering. Can somebody talk? What time do you have your computational team?
Sir, please, we don't have a class after
We don't have
this.
class today. Yeah, we don't have class today.
Okay. Okay, then that's fine. So
they can who are having practicals.
Chemistry practicals too.
At what time?
So we have chemistry practicals.
At what time?
2:30.
Okay. Okay. So I'm doing B. Later, A, the difference between A and B is that you are taking the weight into account, so you can easily do that. So let me draw the free body diagram. So our free body diagram will look like something like this. Once again, we have a rocker. So you take it off and then show 90 degrees. I'll call it as AY. This is a pin. So I'll remove it. And then that. I'll show my AX this way. If you show to the right, it's also correct. Only it will end up to be negative. I know, because this one will go this way. So I'm trying to do it to balance it. If you get negative, please, it's correct too. Oh, so this is B. This is BX. And that is BY. And then there is some load here. Apply on something small that is attached to this. That is 200 newtons. And then there's something here. And then there's a load that is holding it. It could be some weight. And then there's something here. That there's a load applied to. But you don't need to do anything. You could show them directly on the beam. You don't need to show that little things. You can show them directly. But I just want to do something different for you to see. This is 45 degrees. This is point A. And this is 100. That is 200. Let's show the distance there is from here to here is 2 meters. Then there's the weight. So the weight is always at the middle. The whole thing is 7. So it means from here to here is 3.5. And this is 2. And that, so this is 1.5. This point is D. Where did they show C? Did they show C somewhere? They didn't show C. I can put C somewhere here. And I can put G here somewhere here. Take note, there are some few dimensions we can show. Oh, I didn't show this. From here to here, I didn't show. I can squeeze it somewhere. But you don't have to mess up your freeboard diagram. I can put this at 3.5 meters. And from here to here is 2 meters. Okay. And then there's some small thickness. Here they've given the thickness. So that's the only thing I wanted to point out. They've given the thickness to 0.2. Yes, Felician. A says neglect the weight. B means take the weight into account. So I'm doing the B. So if you are doing A, the only thing you not show is this one. So this is 10 times that. 10 times 9.81 is 98.1 newtons. So that's the one you're going to put here. Or you can put the 10G. Yes, so I'm doing B. I'm doing B. A, the only difference is that you don't put the weight. That'll be the only difference. So if I do B means you can easily do A. Let me know whether you've understood what I'm saying. Okay. What will you do? Which equation will you apply first? 3 unknowns. BS, BY, AY. Which equation will I apply first? I'll write them, but I will not write the answers. What will you do first? What will be your main focus?
So please we'll find the AY first.
You find, okay, if somebody can find AY first. If even somebody can find AY first, somebody can. So if you want to find AY first, you can take moment about B is equal to 0. So if you take moment about B is equal to 0, who can help with the equation? So let's do who's going to help me? BY, I always like to write my unknown for BY times 7. And BY is turning the beam that way. BY times 7 is turning this way. What else is turning that way? All of them are coming the opposite. Is that right? BY is the only one turning this way. So this is equal to 98.1 times 3.5 plus 100 times 100 times what? Is it 5? 100 times 5. So I've done this and this. And then I have to do this plus 200 times 7. And then this, if you resolve this, you're going to get 600 cosine and 600 sine. Okay, so plus 600, the sine one, 45, times the distance 2. And then you find BY. I'll leave that one for you to do. Check whether everything is okay for you. Only BY will have a moment on one
So
side.
please, is it moment about A or B?
Oh.
So please, looks like you are taking moment about A.
Okay. Since I've done that, let me do that. Thank you very much. Brilliant. Okay, let me do that one. Since I can find something. Yes. So if you say we are confused, then that I should have done this thing moment about B. But let me do that. Okay. So is everybody okay with what I wrote? So you could also take moment about B, and then you get AY. Since there's going to be only one unknown, I've gone ahead to find that. And then you do some of what do you call it? Oh, I've mixed one term. In fact, that's the reason of me doing this question. I have mixed one term. Who can tell me the term? I've missed one term. You see, if you go to this point here, the thickness, yes. In fact, most of the questions going to come across, we will neglect the thickness. But if you are taking the thickness to account, then what is happening here is that the 600 sine 45 like this, and then the 600 cosine 45 like this. So you have to multiply the thickness, and if you are taking moment about what A, which side would they go? The sine one will try to rotate this way, and then this one will also try to rotate it that way. Is it plus? Can somebody confirm? 600 cosine, you have to add on 45, and you have to multiply by 0.2. You have to multiply by 0.2. That is the only difference I wanted to point out to you.
Sir, please, the 600 cos 45 times 0.2, is it negative or positive?
Let's see. If you put your finger at A, if you put your finger at A, this is point A. You put your finger at A, this one will try to move, pull it this way. So that one, this one is definitely, the sine one will definitely positive. Then what about the cosine one? Just put, if you have a piece of paper, put your finger there and then see how is it going to turn it. Because the arrow is going this way, and this arrow is coming down. Let me make it again. This is coming down, and that is point A. And this is like that. Can somebody enter all this and give me this in the textbook? Then I can. Oh, okay, the textbook don't have the weight. The textbook don't have the weight, so that will cause the difference. Okay, let's do moment about B, and let's see what we get. At least that will cause. Let's do. Can somebody help me with moment? Who want to talk? Moment about B. Who want to help me? Because that's the reason of me writing this. Let's do moment about B. Okay, Lenovo. AY times. Go ahead. Talk.
Sir, please, for the 600 cos 45, wouldn't the thickness
hold on. I said somebody help me to do moment about B. Then you can ask your question. Let's do moment about B. Who want to help? Who want help? We write this together. Moment about B. Okay, Nathan, let's go ahead. AY times. So put your finger at B.
AY times 7.
And AY times 7 is going this way. Okay, what else is going that way? What else is going that way? Let's start with the 600. Let's start with the 600. Break the 600 down and tell me which one is going the same way, turning it about the same way.
Times 5.
The sine one will be pushing down. So the sine one will go this way, but the cosine one will be in the same direction.
Yes.
So this will be 600, and that's the only thing I wanted to show you for this question. 600 cosine 45 times 0.2. Okay, which one else is going the same direction? Which one is going the same direction? And that's it. And this is equal to what? 981.1 times 3.5 plus 100 times 2. Done. The 200 will not have moment. This one will not have moment. The 200 will not happen because it will pass in through B. And that's the only thing. Okay, so you do, either you do this or that. If you do this one, you get BY. If you do this one, you get AY. But please don't waste time and do two movements. It's waste of time. So after you done one movement, let's do summation of forces equal to Y. So you just get AY, I'm coming, AY plus BY is equal to, then you write it down before you do summation of forces in the X. Yes, who want to ask the question?
Sir, please, about, you said you are taking the moment about point B. So if you are taking the moment about point B, why is it that the 600 cos 45 is being multiplied by 0.2?
What do you want us to multiply by?
I thought you are going to multiply by the distance from the cos 45 to point B, which is 5.
If you resolve the 600, you go to get like this. This is 600 sine 45. And this is 600 cosine 45. Oh, okay. Oh, I just missed one term here. Maybe that's your question. There's one term missing here. What is the 600? Is that the one you are pointing out? 45 times, what's the distance? 5. That's only one missing. Yeah, who was asking the question?
Sir, please, I'm the one. But sir, I think the sine 45 should be multiplied by the 0.2 because of the thickness. Then the cos 45 should be multiplied by the 5 because of
Put your
the
finger
movement
at
of the
B.
cos about point B.
Put your finger at B. Hold your finger here.
Okay, I'm done.
After you hold it, see whether this is not going to turn this way. The 45 will turn this way. And this cosine one will try to push it opposite way. Hello? Put your finger at B.
Sir.
If you press the
Okay.
B, if you press that B, the 600 sine 45 will turn in this way. So it will go the same direction as the 98.1, the 600, and so on.
But sir, this one, you're finding the moment of the, we started with 8 AY, that is AY times the distance 7, meaning the it's going to turn it, I think, in the clockwise direction. So if it's turn it in the clockwise direction, that means AY is going to multiply by the perpendicular distance. Then after that, you come to the 600 cos 45.
It's also going the same clockwise.
That is the same clockwise. So what is that the distance from that place to point B is 0.2 instead of 5?
Because the line of action is going this way. And the distance between them is 0.2. There's a line of action. There's a line of action of the cosine one. It goes to our line of action. And the distance between them is 0.2. That's the cosine one. It act, yeah, somebody say it act at the top of the bar. Yes. Okay. I wish we finished so that.
Sir.
Yes. Let me look at quick one
Sir,
question. Yes.
I have a question.
Yes.
Sir, please, the 600 cos 45, is it not supposed to be multiplying 0.1 because the B is at the middle of the beam? It's not at the end of the beam.
Yeah, the thickness is not 0.2. From the middle to the top is what is 0.2. So that's a good question.
Okay, thank you, sir.
But very, very good question. So sometimes they will give the thickness of the beam, then you have to divide by 2. But it just give for the middle line. Let me zoom into it so you can see. They give for the middle line to the top to be 0.2. So that's why I multiply by 0.2. Any more question? So let me say, so in this question, you can decide to take one moment and sometimes don't take two moments. That will be too much waste of time. Take only one moment and then do summation of forces in the Y. Then do summation of forces in the X and you are done. Okay, don't take moment twice, it's waste of time. After you've done AY or you've gotten BY, don't do moment again. Just do sum of forces upward equal to sum of forces downwards. You get the other one. And then you do sum of forces in the X and then we are done. Let me do one more example and then these guys can go for the lab. Okay, somebody read this question. I'll draw a few board, I can do it and then I'm done. I'll I will see you next Tuesday. Okay. We can do the main sermon, everything I've covered up to this point. That's fine. Okay, let's do this one then. Oh, somebody read a question for me.
Determine the tension in the cable and the horizontal and vertical components of the reaction at pin A. The pulley at D is frictionless and the cylinder weighs 80 pounds. Neglect the weight of the beam.
Okay, and if anytime you don't give the mass or the weight of the beam, means we are neglecting it. Okay, so we draw the beam. We draw only the beam. We take everything away, everything else away. You cut the rope. You have to cut this rope. Cut it. And then you show a tension arrow at the end. This is a pulley. What do we say about a pulley? Remember, that is a pulley. We make some assumption for now. We are saying the pulley is what? Frictionless. That is the whatever cable is easy to move, freely to move. Therefore, the tension are the same. So let's call the tension T and a T. This has a weight. The weight will be the same as the tension in the rope. So I'll cut the rope and I'll show tension. But the tension is the weight, and the weight is given as 80 pounds. This point is C, that point is B, and that point is A. Let me call this point D. Now, what is happening here is it's a hinge that is holding it, but the hinge is cantilever into some wall. So the only interest here is the hinge. So this is a hinge, and I'm going to show it as. Let me intentionally do this one so that I'll get negative. I'll intentionally get negative so that when you also get negative, don't panic. I'll put this one here so that this is AX, and then this is. Let me take it up, AY, and let me show the distance is given. This is 5 feet, 5 feet, and 3 feet. And this is point A. So you show everything. And this is our free body diagram. How many unknowns? How many unknowns? How many unknowns do we have here? How many unknowns?
3.
3. That's the maximum we can have. The tension and then the 2 reaction forces at the hinge. And then we are done. Okay, who can help me? What equation should I apply first? This time, straightforward. Which one will you go first? Or what can you find first before you find out the other 2? Which equation should I apply first? That will allow you to find something, then the rest will follow. First, we find T, yes. So if you want to find T, what equation should I apply? We take moment about A. So we say summation of moment about A is equal to 0. Now put my semicolon. Yeah? Now put my semicolon. So who can help me? So we finish this and we are gone. Who can help me write the equation? Let me start. Let me start with this T. Let me start with this T. So T times what distance? 5.
5.
Please visualize by putting your finger at A. Adding. Another T. Oh, there was 2, 1. What? I know some of you like to find the angle, but I don't like the angle, so I'll use the slope. Is this one 5 here? 215 root 5. Everybody okay with that one?
Yes.
2, yeah, root 5. You have to put on it. Or you work the angle and put the angle here. You work the angle and put the angle on free body diagram. I don't mind. Any of them is fine. I've shown how to do that. You can use tan inverse of 2/1, or tan, and then do that. So this is T times which one? The one that is going horizontal will not have moment. The thickness of the rod is being neglected. So this one will not have moment. Yeah?
Yes.
The 1 over root
Yes.
5 will not have moment. The 2 over root 5 will have. So this is 2 over root 5.
By 5.
So T 2 over root 5 is the force resolved. Before you multiply this by 10, that is the distance to get moment. And this is now is equal to 80 times what?
80
13.
times 30.
Done. Have you seen the way I write them? It means you're already one step ahead of rearranging. And then you just use the calculator, factorize T out, make T the subject, work it out. I will not do this. You will do this later. What equation will you go next? Then everything is easy now. You do sum of forces in the Y. Sum of forces in the Y. What do you get? What can help me? AY going up plus T going up plus T what? 2 root 5 is equal to 80. This allows you to get AY because you know T. Then you do summation of forces in the X equal to 0. And what do you get? Let me zoom out before small, then you see. My AX, look at my diagram. Have you seen my AS is going to the left? Plus my T 1 over root 2 is also going to the left. And this is called 0. So AS will come out as negative. Please, it's correct. Don't change anything. Leave the answer like that. Don't change your free body diagram too. If your unknowns support reaction come out negative, don't change anything. They are correct. Unless maybe they are looking for the magnitude, then you say, okay, the magnitude, if the answer is -5, then you say the answer is 5 magnitude. That's all. And sometimes that's what we are interested in, the magnitude of the component support reaction. So I'm done because I people have this. Let them take a break before the alarm. I will see you on Tuesday. We'll communicate because we have to do the IE on Tuesday. And it's up to wherever we got into. I can only give you homework up to where we've got into. Okay, so prepare up to wherever we got into, and the rest will come. So next week we'll meet twice. But what I'll do is that possibly I will do some small recording to finish the 2D. That's what I'll do. I'll do some recording and finish the 2D, and then that's. But we'll communicate through the WhatsApp. Thank you for your time, and then I will see you later. Any question or any comment?
Thank you, sir.
Please, I will it be online?
Yeah, what? No, definitely no. Definitely no. We'll meet at that place. That place that we have the class supposed to be an exams room. So that place is really, really good for exams. So we'll do it there, possibly 2.5 hours or 3 hours. So we'll communicate through the WhatsApp.
Okay, sir, thank you very much for your time. God bless you.
Okay. The recording cannot be posted in WhatsApp, so the recording can only be in the OneDrive, or the TS can move into the Dropbox. Okay. Bye-bye.
Okay.
Bye.
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 Bye.